Here we have 7 somewhat quick introductory examples of using the chain rule, and I recommend on each one that you pause the video and try it yourself as we go along to make sure you're doing these at the same pace. If you don't want to do that for the first couple, that's okay. Maybe you're just still getting the hang of it, but certainly once you can, start pausing the video and trying these on your own to see if you can get them. Alright, so what does the chain rule say? Let's just say it again. The chain rule says that when you have one function inside of another, the derivative of the whole composition is the derivative of the outside. We leave the inside alone, so that's this f prime of u times the derivative of the inside. So a good way to remember it is just the derivative of the outside times the derivative of the inside. And remember, when you take the derivative of the outside, to leave that inside function alone. It's just f prime of u. Don't try to take all the derivatives at once. That's the biggest mistake I see with the chain rule, is everyone tries to do everything at once, right? I get it, we're excited, but you have to really use your patience and just leave that inside function alone. Let's try it. Part A, we have y equals the quantity x squared plus 2x all to the third power. Let's identify our inside and outside functions. The inside function is x squared plus 2x, is literally inside, and then our outer function is something to the third power. Okay, no big deal. So then the derivative, y prime, or dy dx, if you want to write it that way, we'll maybe switch back and forth. Y prime is, okay, we do the derivative of the outside. That's what the chain rule is telling us. So we're going to leave the inside alone and just focus on that outside derivative. So we're using the power rule here. 3 times something squared. That's the power rule. What's that stuff inside? We just rewrite it. X squared plus 2x. Okay, so we've taken care of the outside part. Now we do times the derivative of the inside. Well, the derivative of x squared plus 2x is 2x plus 2. That's essentially the power rule there. And voila, there's our derivative. Let's try part B. We have y equals the quantity 1 plus x squared, all raised to the 99th power. Alright, so the derivative, we'll use the chain rule here. We'll write the dy dx version instead of y prime, because we can use those interchangeably. Dy dx is then, alright, let's leave the inside alone and just focus on the outside. The outside is something to the 99th power. Okay, so we say, let's use the power rule on that. 99 times something all to the 98th. Well, what's that something? Whatever was inside before. So just leave it alone and rewrite it. 1 plus x squared. Notice I didn't try to take the derivative of that inside. Times, okay, now we take the derivative of the inside. How about 2x plus 1? I did it in a slightly different order there, but just to keep it in kind of a descending way. X squared became 2x, x became 1, 1 became 0 when we took the derivative. And there you have it, that's the derivative. Okay, part C, we have y equals sine 2x. Okay, first thing we need to do is identify our outer and inner functions here. So I'd say sine x, that's going to be my outer function, and 2x is my inner function. Alright, so then the derivative, y prime, is, okay, we'll take the derivative of the outer and leave the inner alone. So the derivative of sine x, if you recall, is cos x. But it's cos in this case of 2x because that's what's inside. Note that we just left the inside alone here. That's what our f prime of u means. Our u in this case is 2x. We just leave it alone, and then we do the derivative of the inside. So then what's the derivative of 2x? Well, it is 2. Okay, that's a perfectly fine way of writing the answer. It's a little better, though, to write it as 2 cos 2x. We're just kind of used to seeing it that way. So let's do it that way. Moving the constant out to the front is just a better way to represent answers, generally in math. Okay, on to part D. Part D jumps us up a little bit. We have y equals sine cubed of 3x. And we can kind of start to see why we call it the chain rule here, because it makes a chain of derivatives. Right now we have 3 layers. We have an outer, a mid, and an inner. What in the world do I mean? Well, look. Well, first off, just to avoid any confusion, let's rewrite this as the quantity sine of 3x all cubed. Okay, so now we can see our most outer function is 3, something cubed, something cubed. I'm missing a parentheses, aren't I? There we go. Okay, so we have something cubed, that's our outer, and then our kind of in the middle function is the sine, that's the middle, and then all the way inside is 3x. So you'll see this a lot. You'll have one function inside of another, inside of another, inside of another, right? You can just keep going and going. The chain rule applies and applies and applies. So then dy dx, the chain rule tells us that dy dx equals, all right, so I'm going to do the outermost first, leave everything alone. So 3 times a bunch of stuff squared. What's that bunch of stuff? It's the stuff that's already in there. Sine 3x. Okay, times the derivative of the inside. Well, the next layer in is sine, so the derivative of sine is cosine. Cosine of what? Well, the stuff that's already in there, 3x. Okay, next we do the inside of that. The derivative of the inside, well, the inside is 3x. The derivative of that is 3. And there you have it. Let's just simplify. We can combine the 3 and the 3. So I'll just do that all in one step here because I'm going to run out of room if I keep rewriting things. So let's just write it as 9 out to the front here. 9. And instead of writing this as sine 3x quantity squared, that's not how we usually write things. Instead, I'm going to write it as sine squared of 3x. Right, that's how we write trig stuff. There you go. Okay, on to part E. We have y equals cos of sine x. So in a very important point here, note that this is not cos x times sine x. You'd be surprised at how often I see people try to use the product rule for this kind of example. But this isn't a product, it's a composition, right? What we have here is sine x inside of cos x. So we're taking the cos of something. What are we taking the cosine of? We're taking the cosine of sine x. So it's not cos x times sine x, it is indeed a composition. Well, let's apply the chain rule. Okay, so then y prime is, all right, the derivative of the outer, and we leave the inner alone. So derivative of cosine is negative sine. Sine of what? Well, whatever was in there before, we just rewrite that. So negative sine of sine x. Now we're ready for that inside derivative times the derivative of the inside. Well, what's the derivative of sine? Cosine. Cos x. Can we simplify this further? You may be thinking, well, let's write that as sine squared x. But this is not sine squared x, right? This here is not sine squared x. Sine squared x is sine x times sine x. This is sine of sine x. So indeed, this is as simplified as this one gets. Okay, so really take some time with part E. Just making sure you completely understand that and all that that example encapsulates will help you greatly moving forward, right? Because there's a lot of examples that are like this, such as part F, but just a little more complicated. And then, of course, as the course goes on, we'll get more and more and more and more complicated. But the chain rule always holds, and a big part of it with trig is recognizing when it's a composition and not multiplication. So if you need to pause the video and go back and rework part E on your own, I recommend doing that to make sure you deeply understood that one before we move on to part F. Okay, moving on to part F, we have y equals cos squared of sine x. Okay, so this is a triple. We have a function inside a function inside a function. Again, it may help, at least at first, to write this as something like, let's say, quantity cos of sine x all squared. Because then we can very clearly identify the outermost function, which is the squared. Then we go one layer in, the cos comes next, one layer in from that, sine x is all the way inside. So squared, cos, sine, moving from outside to inside. All right, so then our derivative, y prime, okay, let's do the outside first, 2, and we're just doing the power rule here. Well, 2 comes down, so it becomes a 1 up here. We don't have to write the 1. What's left? Well, we just cut and paste cos of sine x. I didn't alter the inside at all. You have to resist the urge to take a derivative of the inside when you write this first chunk here, right? You just want to copy and paste that. Don't touch it at all. And now we focus on the derivative of the inside. So what's our next layer in? Is cosine. Well, the derivative of cosine is negative sine. Sine of what? Well, whatever's inside it. Well, sine x is inside it. So sine of sine x times the derivative of the inside. Well, what's the inside now? We have sine x on the inside. So that derivative is cosine of x. Cos x. And again, we need to resist the temptation to write this as sine squared x. It's not. It's sine of sine x. Same thing here. We can't write this cos and this cos as somehow cos squared x because they're different things on the inside. When the inside of cosine or sine are different, we can't combine them into a single function or something like that. So what can we do to simplify this? Not much. All we can really do here, and let's see, let's just bring it down. Maybe we can say equals, is we can bring this negative out to the front. That's it. Negative 2 cos of sine x times sine of sine x times cos x. Cos x, I'm running out of room. There you go. And for part G, the last one, we have y equals e to the power of the quantity x squared plus 2x plus 1. All right, so let's do the derivative. We'll say dy dx is then, okay, well, here we have our outside function is simply e to the whatever. So there's our outer, and our inner is all this x squared plus 2x plus 1. So let's do the derivative of our outside function first and leaving the inside alone. Well, what's the derivative of e to the anything? It's e to the anything again. So the outer derivative is simply, we just rewrite it. E to the what? Well, whatever was in there before. X squared plus 2x plus 1. Now we multiply, so times the derivative of the inside. Well, derivative of x squared plus 2x plus 1 is 2x plus 2. There we go. And now we can clean this up a little bit. Let's see, equals, maybe bring this 2x plus 2 out to the front and write that as e to the x squared plus 2x plus 1. Okay, so that part G might be another one to go back and rework a couple times and make sure you deeply understand how those e derivatives work. Technically, that's probably the easiest one on here, but it's also the easiest one to make mistakes on, or at least it can be, if you don't just trust. Like the first thing you do is just essentially rewrite the function as it's given. So people really get nervous about, really, I just rewrite it? That's it? Yeah, that's it. And then the derivative of whatever's inside the e. That's all there is to it. It's easy to make it more complicated than it needs to be. So if you tripped over any of these, go back and rework them. Maybe later tonight rework them. Go back tomorrow and rework them. Right? You want to be able to do these pretty much in your sleep by the time we're done with the chain rule.